Electronics cooling in Fusion 360 enables you to simulate the temperature that components on an electronics board are likely to reach to determine whether the board is viable or if changes should be made. In this video, we set up an electronics cooling study to analyze the effect of heat-generating electronics components on the board and surrounding air volume. You can analyze an electronics design that was modeled in any CAD software. In this video, we analyze a design that was created in Fusion 360. This model is an assembly that includes 3 boards and an enclosure. To create an electronics cooling study, we need to switch to the simulation workspace and select Electronics Cooling. The Settings dialog is where you can set the ambient temperature, provide an informative name, and select what balance you want between speed and accuracy. You can edit these settings later if you need to. Notice that the electronics cooling study is associated with a simulation model. A useful feature in Fusion 360 is that you can create new simulation models, modify them, and analyze the changes without impacting the original model in the design workspace. Let's hide the data panel and set up the electronics cooling study ready for analysis. As with everything in Fusion 360, you work your way along the ribbon from left to right. Often you can speed up a simulation analysis by manually removing details from the model components using the tools in the Simplify environment. In an electronics cooling analysis, this simplification is done automatically by the solver. The air volume around the board is also built automatically. The first task is to check the materials. Confirm that all the board components use appropriate materials, and fix any with warnings. The only other study setup requirements are to set a thermal load on appropriate board components and to define fan attributes if the model includes fans. Since this model has no fans, we need only set the heat loads. For electronics boards modeled in Fusion 360, if the thermal loss for the materials were defined during the modeling process, the heat loads are imported automatically into the electronics cooling study. In this example, this wasn't done and we'll set the loads manually. In the browser, expand the Model Components folder to see all the components. We want to set heat loads on these 3 boards. Use the browser to show and hide components to make the job easier. On this main board, we'll set a heat load of 2 watts on this component. Click the internal heat icon to open the Thermal Loads dialog. Click on the component in the model to select it, and then type the heat load and press Enter to accept the value. Repeat the process to set 0.2 of a watt on these components, 0.1 of a watt on these components, and 0.08 of a watt on these components. You can see the internal heat loads you've assigned and edit them individually here in the browser. Or you can see them all in one place in the Load Case Attributes dialog and edit them from here. At this point, the pre-check status confirms that there is enough information to run the analysis. While it's not required to solve the analysis, you can click Critical Temperatures to manually set critical temperatures on board components to highlight those that might overheat or fail. If your electronics design was modeled in Fusion 360 and the maximum temperature was set in the electronics design, this information is brought into the electronics cooling study automatically. Now we are ready to solve. Electronics cooling studies can only be solved on the cloud. When the analysis is complete, results are streamed from the cloud to provide you with immediate access to them and to eliminate the disk space requirements of large result files. Click Results to open the results viewer. The default result you see depends on your study setup. If you set critical temperatures on components, the risk factor result loads, showing you only those components with critical temperatures. This result helps you to focus on critical components that may fail due to overheating. If you haven't set critical temperatures, then the temperature view loads instead. This result view shows you the temperature of all the components in the model. You can switch between these results using these buttons. The section plane tool enables you to examine both the temperature of the solid components on the board and the temperature and velocity of the surrounding air volume more closely.